Ever wondered how AI could predict what's going to happen next in a video? Like, how does a computer figure out that someone is about to pour coffee after watching them grab a mug? Well, researchers are tackling this challenge with a clever new approach called bidirectional action sequence learning. Let's break down what makes this study so exciting and why it's a big deal for AI and video understanding. The key idea here is simple but powerful. Instead of just looking forward to predict future actions, the model also learns from the past. Think of it like watching a movie and trying to guess the ending and the beginning. By combining both directions, the AI gets a richer picture of what's happening. This is especially tricky for long-term predictions, where the action sequence can stretch over minutes. Traditional models typically analyze a few seconds of video and guess the next few actions. But here's the problem: they only look forward. Imagine trying to predict a recipe by only watching the first few steps. You might miss the critical part where the chef flips the pancake. These systems struggle with complex scenes where actions are layered, like a person washing a knife and then serving pasta in a kitchen. The context gets lost. Enter BiAnt, a groundbreaking approach from researchers at Panasonic and Chubu University. Their secret weapon: a large language model, like the AI behind chatbots, trained to think both forward and backward. Think of it as a detective who not only predicts the next clue, but also works backward from the ending to piece together the whole story. Here's how it works. During training, the model doesn't just look at past actions to guess the future. It also reverses the process. For example, if the video shows someone putting a knife in a drawer, the model might ask, "What actions led to this?" Then, it uses both perspectives to build a more complete picture. This bidirectional training helps the AI understand why actions happen, not just what comes next. The math behind this: well, it uses something called cross-entropy loss to measure how wrong the predictions are. The model tweaks its answers until it gets better at matching the real actions. And here's the kicker: it combines both forward and backward predictions into one big training loss, giving equal weight to learning from the past and future. But there's a tiny but powerful trick: task description tokens. These are like cheat codes that tell the model, "Hey, we're doing forward prediction here," or "Now, let's try backward." Adding these tokens improved accuracy by a noticeable margin, proving that clear guidance helps the model learn better. On a big dataset of first-person videos called Ego 4D, BiAnt outperformed other methods. It wasn't just better at guessing verbs or nouns, it crushed it at predicting full action sequences. Imagine a video of someone doing laundry. BiAnt could track the whole flow, from grabbing a shirt to folding it, while older models might miss the bigger picture. The key metric: edit distance, which measures how close the predicted actions are to the actual ones. And BiAnt, it's a clear winner. Why does this matter? Long-term action prediction isn't just a tech toy. It's key for robots, smart assistants, or even safety systems that need to anticipate human behavior. By thinking in both directions, BiAnt shows how AI can start to understand actions the way we do, by seeing how they fit into a bigger story. So the next time you watch a video, think about how much the AI behind the scenes is learning from every frame. This study isn't just about predictions. It's about teaching machines to see the full story, one action at a time. Thanks for watching, stay curious, and let's keep exploring the future of AI together. If you want to dive deeper into how AI deciphers video sequences, hit that subscribe button. And let me know in the comments, what's one action you'd love to see AI predict? We'll see you in the next episode.